LangGraph state management mechanism employs dependency injection to decouple tool arguments from their runtime context, enabling dynamic state propagation through a controlled initialization pattern. This design allows components to receive their dependencies from an external source rather than constructing them internally, which enhances modularity and testability in stateful workflows. We are about to examine the InjectedState class, which serves as the foundational abstraction for this injection pattern, where the constructor accepts an optional field parameter to specify the target state attribute. The upcoming code will reveal how this minimal interface establishes the contract for state injection while deferring the actual dependency resolution to the framework's runtime environment.
Injected state. Self. Field. str none equals none.
The InjectedState class serves as a marker for state injection in tool arguments, allowing specific fields to be dynamically populated from the execution context. This pattern enables tools to receive contextual data without explicit parameter passing, which is particularly useful in workflows where state needs to be shared across multiple tools or steps. The implementation is straightforward, accepting an optional field parameter that specifies which state property should be injected. When field is none, the entire state is injected, providing flexibility in how tools consume contextual data. This design choice simplifies tool integration by abstracting state management, though it requires careful handling to avoid unintended side effects from shared state mutations. This approach is beneficial in scenarios where tools need access to shared context, such as user sessions or workflow metadata, without tightly coupling them to the state structure. However, it introduces implicit dependencies, which can make debugging more challenging if not documented clearly. The trade-off here is between flexibility and transparency, making it suitable for dynamic workflows but requiring disciplined state management practices. Let's break it down line by line.
Field. str none equals none.
Declares an optional string field named field with a default value of none, using Python's type hinting syntax to indicate it can be either a string or none. LangGraph's dependency injection pattern for state management hinges on the InjectedState class, which acts as a minimal contract for dynamic state propagation. The optional field parameter is the linchpin here. When specified, it targets a particular state attribute for injection, while omitting it injects the entire state. This design choice deliberately defers dependency resolution to runtime, enabling tools to consume contextual data without hard-coded coupling. The trade-off is clear. Flexibility in state sharing comes at the cost of implicit dependencies, demanding disciplined documentation and state handling. By abstracting state management into this lightweight interface, LangGraph balances modularity with the practical needs of dynamic workflows, though it shifts the burden of clarity to developers to avoid debugging pitfalls.
The state injects the tool that injects the state. What fills the void between them?